Hello, everyone. This is the recorded lecture for week 3 of the Information Assurance and Security 2 subject, which is about software vulnerabilities. Software vulnerabilities refer to weaknesses or flaws in computer software that can be exploited by attackers to compromise the security of a system. These vulnerabilities can be unintentionally introduced during the development process or arise due to design or error in the code. When attackers discover and exploit these vulnerabilities, they can gain unauthorized access to data, disrupt services, or execute malicious code on the affected system. There are several types of software vulnerabilities to be presented in this slide. The rest will be discussed by details. So we have first the buffer overflow. This occurs when a program tries to write more sensitive data or more data to a buffer or the temporary storage that it can hold, leading to overwriting adjacent memory areas which can be exploited to execute malicious code. We also have SQL injection. In web applications, improper handling of user supply data in SQL queries can allow attackers to insert malicious SQL code, potentially giving them unauthorized access to databases or sensitive information. Then we have cross-site scripting or XSS. Attackers inject malicious scripts into web pages viewed by other users, allowing them to steal sensitive information or take control of the victim's session. The other one is cross-site request forgery. This exploits the trust that a website has in a user's browser by tricking it into making unintended, potentially malicious requests to another website where the victim is authenticated. In privilege escalation, some software may have vulnerabilities that allow attackers to elevate their privileges and gain more access rights than they should have. Remote code execution allows attackers to execute arbitrary code on a target system remotely, often through exploitable vulnerabilities in network services. Then lastly, we have denial of service, where attackers flood a service or system with excessive requests, causing it to become overwhelmed and unavailable to legitimate users. We have another one. We have the authentication bypass. Security mechanisms can be bypassed, allowing attackers to gain unauthorized access to system or resources. Okay, so to mitigate software vulnerabilities, developers should follow secure coding practices, regularly update software with patches and security fixes, conduct security audits and code reviews, and employ various security tools and techniques. Users should also keep their software up to date, be cautious when downloading files or clicking on links, and use strong, unique passwords for their accounts. Security researchers and organizations often discover and disclose vulnerabilities responsibly to software vendors, allowing them to issue patches before attackers can exploit them. Buffer overflow is a type of software vulnerability that occurs when a program tries to write more data into a buffer or the temporary storage area than it can hold. Buffer are used to store data temporarily, such as user inputs or network packets, before the program processes it. When the data exceeds the buffer's capacity, the excess data can overflow into adjacent memory areas, potentially overwriting the critical data or code. This vulnerability can be exploited by attackers to execute arbitrary code, crash a program, or gain unauthorized access to the system. The consequences of a successful buffer overflow attack can be severe, ranging from unauthorized access to the system to the execution of malicious code with elevated privileges. So here are the basic steps of a buffer overflow attack. First is identification, wherein attackers identify a vulnerable program with a buffer overflow vulnerability. They typically use techniques such as code analysis or fuzz testing to find such vulnerabilities. After that, we have crafting malicious input. So in this phase, the attacker creates input data that is intentionally designed to exceed the buffer's capacity. They insert additional data containing malicious codes or shellcode into the input. After that is triggering the overflow. The attacker sends or injects the crafted input into the vulnerable program, causing the buffer to overflow. Then, overwriting data or control flow. The excess data overrides the adjacent memory, which can include critical data structures, function return addresses, or even the instruction pointer. So by modifying the program's memory layout, the attacker gains control over the program's execution flow. Of course, we have the execution of malicious code. So if the attacker successfully overwrites the instruction pointer or returns address, they can redirect the program's flow to the malicious code they placed in the input. So this allows them to execute arbitrary code with the privileges of compromised process. So to prevent buffer overflow vulnerabilities, developers should follow secure coding practices such as input validation and boundary checks. So when handling user inputs or external data, then using safer programming languages that include built-in safeguards against buffer overflow, such as Rust, Go, or Python, which can help mitigate this type of vulnerability. Regular security audits would also help, code reviews, and penetration testing, which can also identify and address potential buffer overflow issues in software applications. SQL injection is a type of security vulnerability that occurs when an attacker manipulates a web application's input fields or parameters to execute malicious SQL queries against the underlying database. So you could relate to this more because of the SQL experience that you had and will be having with the development of your systems. So SQL injection attack exploits improper handling of user supply data, allowing attackers to gain unauthorized access to a database, manipulate data, or perform other malicious actions. So the process of a SQL or an SQL injection attack typically involves the following steps. First, attackers identify the web applications that are vulnerable to SQL injection by looking for input fields such as login forms, search boxes, or other user input areas that do not properly validate or sanitize user input. So you should consider this when creating your applications that it should be properly validated or sanitized. Next is crafting malicious input. So the attacker carefully crafts input data, often by adding specially crafted SQL statements or fragments to manipulate the original query. For example, an attacker might append a single code to terminate the SQL query and add their malicious code. Okay, look back on how you create an SQL query. You would observe that this is possible. Next, we have injecting the malicious input, wherein the attacker submits the manipulated input to the application, which is then processed by the server and used in constructing an SQL query. So after that is the exploiting the vulnerability. So if the application does not properly validate or sanitize the input, the manipulated SQL code will be executed by the database server. Depending on the severity of the vulnerability and the attacker's skill, they can perform various actions such as extracting sensitive data, modifying or deleting data, or gaining administrative access. To prevent SQL injection vulnerabilities, developers should follow secure coding practices, which includes parameterized queries. So instead of directly inserting user input into SQL queries, used parameterized queries or prepared statements which separate the SQL code from the user input. So this approach ensures that the user is treated as data rather than executable code. Then we also have input validation and sanitation, as mentioned earlier. Validate and sanitize all user-supplied input to ensure it conforms to expected formats and contain no malicious code. List privilege. So limit the database users' privileges to only those necessary for the application's functionality. Avoid using privileged accounts for normal applications. Escaping special characters. So you should know this, how to use it, so you could apply it to your system. So if dynamic SQL generation is unavailable, properly escape or parameterize input to prevent SQL injection attacks. Firewalls, web application firewalls. So implement a WAF to help detect and block malicious SQL injection attempts. This would also help conduct regularly security audits and penetration testing to identify and address any potential SQL injection vulnerabilities. So by implementing these best practices, developers can significantly reduce the risk of SQL injection and enhance the security of their web applications. Okay, cross-scripting or cross-site scripting or XSS. This is a web security vulnerability that allows attackers to inject malicious scripts into web pages viewed by other users. So the primary objective of XSS attacks is to execute arbitrary code within the context of the victim's browser, steal sensitive information, or perform actions on behalf of the victim. So there are different types of XSS attacks. The first is the stored or persistent XSS. The malicious script is permanently stored on a target server, typically in a database or a comment section. When the other users view the affected page, the script is served to their browsers and executed. We also have reflected or non-persistent XSS, wherein the malicious script is embedded in a URL or a specific HTTP request parameter. When a victim clicks on a crafted link or submits a form with manipulated data, the script is reflected back from the browser and executed in the victim's browser. We also have DOM-based XSS. So the attack occurs entirely on the client side, where the malicious script manipulates the document object model or DOM of a web page. The vulnerability arises when a client-side script does not properly validate or sanitize user-supplied data before using it to modify the DOM. XSS attacks are dangerous because they allow attackers to take advantage of the trust between a website and its users. By injecting malicious scripts into legitimate pages, attackers can steal sensitive information like login credentials, cookies, or session tokens. They could also impersonate users or perform actions on behalf of the user without their consent. They could also deface websites or spread malicious malware to other users and perform phishing attacks to trick users into revealing personal information. To prevent XSS vulnerabilities, web developers should follow these best practices. First, we have input validation and output encoding. Validate and sanitize all user supply data on the server before rendering it on web pages. You should apply this suggestion to your pages. Use output encoding or HTML scaping to ensure that the user input is treated as a plain data rather than executable scripts. HTTP only and secure cookies. Use HTTP only and secure flags for cookies to prevent them from being accessed or manipulated through client-side scripts. Implement a content security policy that specifies which sources of content, such as scripts, images, and style sheets are allowed, thereby mitigating the impact of XSS attacks. HTTP headers. Utilize security-related HTTP headers like XXSS protection, X content type options, and X frame options to enhance security in the browser. You could read more of these ideas online. The resources are available online. Avoiding inline scripts. Minimize the use of inline scripts and consider using external JavaScript files, which are more secured. Of course, the regular security testing. Conduct regular security audits and vulnerability assessments, including code reviews and penetration testing, to identify and address potential XSS vulnerabilities. By adopting these security measures, web developers can significantly reduce the risk of XSS attacks and create more robust and secure web applications. Next on the list is the cross-site request forgery, or CSRF, which is a web security vulnerability that allows an attacker to perform unauthorized actions in behalf of a victim user. The attack takes advantage of the trust between a user's browser and a website by tricking the user's browser into making unintended, potentially malicious requests to another website where the user is authenticated. CSRF attacks typically involve the following steps. First is authentication, wherein the victim user logs into a website and gets authenticated, receiving a session cookie or other authentication tokens that prove their identity to the server. And then the attacker creates a malicious website that contains a hidden or disguised form or URL. This form will trigger actions on website A, such as changing account settings, making financial transactions, or submitting sensitive data. Okay. Next, the attacker entices the victim user to visit the malicious website. This could be achieved through social engineering, spam emails, or other deceptive techniques. You would also notice some text messages that you receive containing some links that are encouraged to be clicked. So let's be aware of this situation so we can avoid it. When the victim visits website B or the malicious website, their browser automatically sends requests to the first website, the authenticated one in the background, using the victim's stored authentication credentials as part of the request. Okay, next is the execution of the transaction on the first website, the authenticated one. Since the request comes from the victim's browser with valid authentication credentials, the first website, or website A, mistakenly interprets the request as legitimate and executes the action on the user's behalf, effectively performing the attacker's intended actions. CSRF attacks can have serious consequences such as changing account settings, making unauthorized purchases, deleting data, or performing actions that compromise the user's privacy or security. To prevent CSRF vulnerabilities, web developers should implement the following security measures. First, we have the CSRF tokens, which include anti-CSRF tokens in web forms or as part of URLs to validate a request that a request originates from an authorized source. These tokens should be unique for each user sessions and automatically generated by the server. The web frameworks that are available, such as the one under MVC, usually have implemented these kinds of security measures which you could apply. That's one of the advantages of having a web framework rather than the native coding. Because in native coding, you still need to encode everything. You have to apply everything from scratch. Okay, next security measure is the same site attribute. So in this case, we set the same site attribute for cookies to control when cookies should be sent with requests, helping to mitigate CSRF attacks. HTTP referrer header. Check the referrer header on the server side to ensure that requests originate from expected source. However, note that this header can be spoofed, so it should be used in conjunction with other protection mechanisms. Log out after inactivity. This is a very good suggestion. You give some time for the user to be online, and then if there's an absence of activity, you should automatically log out the account. So in this time, you implement session timeout mechanisms for the web applications or the website. HTTP headers. Utilize security-related HTTP headers such as X, CSRF token, and X content type options to enhance security in the browser. And of course, the regular security testing. We conduct security audits and vulnerability assessments to identify and address potential CSRF vulnerabilities. So by implementing these security practices, web developers can significantly reduce the risk of CSRF attacks and protect their users from unauthorized actions performed on their request, on their behalf. Privilege escalation is a security vulnerability that occurs when an attacker exploits a weakness in a system or application to gain high-level access or permissions that they are initially authorized to have. The objective of the privilege escalation attacks is to elevate the attacker's privileges from a standard user to a privileged user, such as an administrator or a system-level account. This increased level of access allows the attacker to perform actions that would otherwise be restricted and gain greater control over the compromised system. There are two types of privilege escalation. First is the vertical privilege escalation. This occurs when a standard user attempts to gain the privileges of a high-level user, such as an administrator or a root user. This attacker exploits vulnerabilities, misconfigurations, or design flaws in the system or application to achieve this goal. Next is the other one is horizontal privilege escalation. In this scenario, an authenticated user attempts to gain access to another user's account within the same privilege. This can happen when there are weak authentication mechanisms or insufficient access controls. Privilege escalation attacks can happen through various means, which includes exploiting software vulnerabilities, wherein an attacker can exploit security flaws in the operating system or applications to execute and gain elevated privileges. We also have misconfigured access controls. Incorrectly configured permissions or access control lists can allow unauthorized users to access sensitive resources. If a system or application has default credentials that are not changed, attackers may use them to gain higher privileges. This was discussed before, and it still applies to the other types of attacks. Exploiting weakly protected services. Services running with elevated privileges might have weak security configurations that attackers can exploit. Then buffer overflows. A discussion before. Similar to how they are used in other attacks, buffer overflows can be employed to override memory and execute malicious code with elevated privileges. Okay, so to mitigate this privilege escalation attack, here are some suggestions for implementing your applications. First is the principle of least privilege. Regular updates and patching, secure configuration, strong authentication and authorization, and then auditing and monitoring. These were discussed before. The idea is they should be applied in the web applications to ensure that there's no attack like this could happen. And if ever there are, you are more secured and ready to address the attack. Another kind of attack is the remote code execution or RCE. So this one is a severe security vulnerability that allows an attacker to execute arbitrary code on a target system or application from a remote location. RCA occurs when a software application or system fails to properly validate or sanitize user input or external data, which allows attackers to inject malicious code that is then executed by the application or system with the same privileges or as the affected process. So RCE could lead to a devastating consequences, as the attacker can take full control of the compromised system, gain unauthorized access to sensitive data, disrupt services, and potentially spread malware to other connected systems. Common causes of RCE vulnerabilities include code injection, wherein attackers inject malicious code such as shellcode or operating system commands into input fields parameters that are not properly validated by the application. Deserialization vulnerabilities. Some programming languages and frameworks allow objects to be serialized into data and then deserialized back into objects. If the deserialization process is not properly secured, it can lead to RCE if malicious crafted data is deserialized. Command injection, so similar to code injection, command injection occurs when an attacker injects malicious commands into an application that executes them on the underlying system. So if an application does not properly validate uploaded files, an attacker can upload a malicious file containing executable code that gets executed on the server. Then we have the remote file inclusion, RFI, or the local file inclusion. So if an application includes files from external or local sources without proper validation, attackers can manipulate the file inclusion process to execute malicious code. To prevent RCE vulnerabilities, developers and system administrators should follow these best practices, which include input validation and sanitation. So again, validate and sanitize all user supply data and external inputs before using them in code execution processes. Follow secure coding guidelines and avoid using unsafe functions or methods that may lead to RCE vulnerabilities. Ensure that the application and its components run with the minimum necessary privileges to limit the potential impact of a successful RCE attack. Use safe APIs. When executing code dynamically, use safe APIs or libraries that mitigate RCE risk. Patch management. Keep all software libraries and frameworks up to date with the latest security patches to address known vulnerabilities. Web application firewall. Implement a WAF to detect and block attempts to exploit RCE vulnerabilities. Regularly perform security assessments, including penetration testing and code reviews to identify and address RC vulnerabilities in the application. By adopting these security measures, organizations can significantly reduce the risk of remote code execution vulnerabilities and enhance the overall security of their systems. This is a more familiar kind of attack, the denial of service or DOS. It's a type of cyber attack that aims to disrupt the availability of a computer system, network, or service, rendering it inaccessible or significantly degrading its performance. The goal of a DOS attack is to overwhelm the targeted system's resources such as bandwidth, processing power, memory, or network connections, making it unable to respond to legitimate user requests. There are several common types of DOS attacks. First is the volumetric attacks. These attacks flood the targeted system or network with a massive volume of traffic, overwhelming its capacity. Examples include UDP flood, ICMP flood, and DNS amplification attacks. We also have protocol-based attacks, which exploit vulnerabilities in network protocols or application protocols to consume system resources, such as SYN flood attacks, to exploit the TCP handshake process to exhaust server resources. Application layer attacks. These attacks target the application layer of a system, aiming to exhaust resources or exploit specific application vulnerabilities. For instance, HTTP flood attack sends a large number of HTTP requests to consume server resources. Distributed denial of service or DDoS. This attack involves multiple compromised devices forming a botnet to launch coordinated attacks against a target. So we are familiar with distributed systems. So it happens in this kind of system. This amplifies the attack's impact and makes it more challenging to mitigate. The consequences of successful DOS attacks can include service disruptions, leading to financial losses and reputational damage for businesses. Unavailability of critical resources such as websites, email servers, or online services, impacting users' ability to access or utilize them. Disruption of network infrastructure. This affects the communication and connectivity of users and systems. So in some cases, DOS attacks may be used as a distraction or smokescreen to conceal other malicious activities such as data breaches or network intrusions. So mitigating DOS attacks requires a combination of proactive measures and response strategies, which include network and infrastructure hardening, implement security best practices such as configuring firewalls, routers, and servers to filter and handle excessive traffic effectively. DOS mitigation technologies. Deploy dedicated DOS mitigation solutions such as intrusion prevention systems, load balancers, and traffic analyzers to detect and mitigate attacks in real time. Traffic filtering and rate limiting. Apply traffic filtering mechanisms to discard and or block malicious or suspicious traffic at the network perimeter. Implement rate limiting policies to prevent resource exhaustion caused by excessive requests. Redundancy and scalability. Design systems and networks with redundancy and scalability in mind to distribute and handle traffic effectively during the periods of high demand or attack. Um, Incident response planning. This can be used to quickly detect, analyze, and mitigate DOS attacks. This includes establishing communication channels, coordination with internet service providers, and coordination with law enforcement if necessary. Monitoring and alerting. Employ network and system monitoring tools to detect anomalies, traffic spikes, or indicators of a potential DOS attacks. Configure alerts to promptly notify security teams. These are a lot of mitigation strategies. By implementing these preventive measures and having a well-prepared incident response plan, organizations can enhance their resilience against DOS attacks and mitigate their impact on operations and services. Last on the list of our software vulnerabilities is the authentication bypass, which refers to a security vulnerability that allows an attacker to gain unauthorized access to a system or resources without providing valid credentials or going through the intended authentication process. So in an authentication bypass attack, the attacker finds a way to circumvent or bypass the authentication mechanism, gaining an access to restricted areas or privileged functionality. Um, there are several methods through which authentication bypass can occur. So just like the other kinds of attacks, weak authentication implementation. So this could create flaws that can be exploited, like using weak passwords, predictable or default credentials, or not enforcing strong authentication requirements. Vulnerabilities in authentication flows. Errors or oversights of the implementation of these authentication flows can create opportunities for attackers to bypass the process. So, for example, not providing validated or enforcing steps like account lockouts, password resets, or multi-factor authentication. Session management issues. Inadequate session management can lead to authentication bypass vulnerabilities. This may include session fixation, session hijacking, or session replay attacks, where an attacker can assume the identity of a legitimate user without valid credentials. Insecure direct object references. If an application does not properly enforce authentication checks, the attacker can manipulate object references to access resources or functionality that are not authorized to access. Flaws in password reset mechanisms. Weak or flawed password reset processes can allow an attacker to reset passwords or bypass authentication altogether. This could involve exploiting predictable reset tokens, insufficient identity verification, or insecure channels. Authentication bypass vulnerabilities can have severe consequences, such as unauthorized access to sensitive data, account takeovers, privilege escalation, or the ability to perform unauthorized actions on behalf of legitimate users. So to prevent authentication bypass vulnerabilities, developers and system administrators should follow these best practices. First, we have the secure authentication mechanism. So you can implement this to provide more security to your data or system. This include strong password policies. The one that I mentioned before, the use of combinations of special characters, lowercase, uppercase letters, and at least 8 combinations of those would create a strong protection for access in your website. Also, multi-factor authentication, so multiple layers of um, authentication. So, pwedeng OTP or something like that. And secure session management practices. Okay, enforce secure management practices such as using unique session identifiers, expiring sessions after a period of inactivity, and properly handling session-related tokens or cookies. Robust authentication checks. Implement proper authentication checks throughout the application to ensure that authenticated users have the appropriate privileges to access resources and perform actions. Thorough test and code review. So you conduct a comprehensive security testing, including penetration testing and code reviews to identify and address potential authentication bypass vulnerabilities. Regular updates and patching. So you keep all software frameworks and libraries up to date with the latest security patches to address known vulnerabilities. Then we have monitoring and logging. Implement robust monitoring and logging mechanisms to detect and respond to any suspicious or unauthorized access attempts.